You have this page in your packet, so if you could take it out, it's a full sheet. As we go through the notes, fill in all these different boxes. So looking at corresponding angles when you have parallel lines, would they be congruent or supplementary? And what kind of equations do we make when things are congruent or supplementary? The first set that we have are corresponding angles. So corresponding angles, if you have two parallel lines, corresponding angles are congruent. So in that first box there, you can fill in that corresponding angles are congruent. How do we know these lines are parallel? Well, there's a symbol in geometry that means parallel. If you see two little arrows drawn on your lines, then we know that those lines are parallel. You could also see it written out as A is parallel to B with two vertical lines. That symbol right there means parallel, just like the upside down T meant perpendicular. Okay, so if we look at this picture, let's say I choose angle 1. Well, angle 1 has to be congruent to its corresponding angle, which would be 5. So 1 and 5 must be the same value. Maybe 1 is 100 and 5 would be 100. So angle 1 and angle 5 would be congruent. We also have corresponding angles 3 and 7. So angle 3 and angle 7 would be congruent. We have 2 and 6. If we are dealing with parallel lines, those would be congruent. And 4 and 8. And again, all those things come into play that you already know. Vertical angles are congruent. You can have a linear pair that adds up to 180. If you look at your picture here, 1 and 4, those are technically vertical angles, so they have to be the same measure. So 1 would be congruent to 4, which is 100. And 4 and 8 are corresponding, so 8 is also 100. We also know that 1 and 2 are a linear pair. So if 1 is 100, 2 must be 80. 2 is 80, we know 6 is 80 because they're corresponding. 6 and 7 are vertical angles, so they also must be congruent. So just by knowing one angle measure, we can fill in all of the rest. So if you think about this, when we have corresponding angles that are congruent, if we had an algebraic expression for those, we would be setting them equal. So the type of equation that you could make is that you could set them equal. Next on our list, we have alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. And again, we have our parallel lines, so if they're both facing the same way, then they're creating the same set of angles above and below. You can have more than one set of parallel lines. We could add in a third, as many as you wanted. I know that doesn't look parallel, but just trust me. And you can still create the same sets of angle pairs. So if we look at this picture, alternate interiors must be congruent. So 3 and 6, as well as angle 4 and 5. Those angles have to be congruent. If they're congruent, you are going to be setting them equal if we need to use that to solve for a value. Next we have alternate exterior angles. Alternate exterior angles, if two parallel lines are cut by a transversal, those angles are still congruent. So we sense a theme here. If, again, I see my parallel lines, now we want to look for alternate exterior angles, like 1 and 8. And on your diagrams, if you just want to circle one pair so you know which ones which kind of angles you're looking at, that might be helpful. We also have 2 and 7. These alternate exteriors are congruent, so again we would set them equal if we needed to make an equation with them. Next we have consecutive interior angles. So when 2 parallel lines are cut by a transversal, the consecutive interior angles are supplementary. So instead of them being congruent, they're now supplementary. So those would be angles 3 and 5, and 4 and 6. So instead of those being equal to each other, they are supplementary. So if angle 3 is 70 degrees, angle 5 must be 110. The equations we would make are that we would combine them, and they're going to be equal to 180 instead of each other. So 3 and 5 are supplementary, 4 and 6 are supplementary here. This is just a little review of a few things that we have talked about in the past. First is a linear pair. Linear pairs are any 2 angles on a line. Remember that they're adjacent angles, like 1 and 2. If they're on a line, they have to add up to 180. So if we just focus on angle 1 right now, angle 1 and angle 2 are a linear pair. We also have angle 1 and angle 3 that are forming a linear pair. In addition to that, we have angle 3 and angle 4 that form a linear pair. And finally, angle 4 and angle 2 form a linear pair. So within one set of angles, we have 4 different linear pairs. Linear pairs, remember, are always supplementary. So the equation that we can make is to combine them and set them equal to 180 degrees. Down below you have the same concept happening. We have angle 5 and angle 6 that are linear pairs, angle 5 and angle 7 that are linear pairs, angle 7 and angle 8 that are linear pairs, and angle 6 and angle 8 that are linear pairs, all adding up to 180. Next, we have vertical angles. As you know, vertical angles are congruent. Vertical angles are directly across from one another. So if we focus on angle 1 again, 1 and 4 are vertical angles. We also could have 5 and 8. On the other side of that, we have angle 2 and angle 3 that are vertical, and 6 and 7. If they're congruent to each other, then the equation that you can always make is to set them equal. Lastly, we have a perpendicular transversal theorem. If a transversal is perpendicular to one of your parallel lines, and we need our arrows to show that they're parallel, then it has to be perpendicular to the other. So if you see that one right angle there, and you know there's 4, that means that the line below, if they're parallel, also has to be making 4 right angles. These are also corresponding angles, and corresponding angles should be congruent when you have parallel lines. Alright, so we've gone through that whole worksheet. Use that, keep that handy while you do your practice problems today. I do want to talk about a couple problems that might be a little bit tricky here. So sometimes we see multiple parallel lines, And you're going to have multiple variables. So we have 4x and we have a 3y. When we're creating equations in algebra, we don't want to put an x and a y together unless we're graphing. So what we want to do here is only create an equation using an x and only create an equation using a y. So first, let's figure out how we could make an equation with 4x. So 4x is over there. Right now, 4x and 56, they don't have a relationship. But we just learned something about corresponding angles, alternate interiors, all kinds of different things. So I could maybe use 56 and its linear pair to help me out. Well, if this angle is 56, to find this angle, we could do 180 minus 56. So there we would get 124. Well, now 124 and 4x, those are corresponding angles. And we just said that corresponding angles are congruent. So my equation would be to set them equal. 4x is equal to 124. By dividing, you can solve for your variable. So x would be 31. Well, we used that once. Now we also want to use it to help us find y. We figured out that 124 is right over here. What kind of angles would 124 and 3y minus 11 be? Well, those would be alternate exteriors. And we said alternate exterior angles are congruent. So 3y minus 11 would be equal to 124, and then you could solve that out as well. Another example that we have for you, and this is actually number 3 from your study guide worksheet, so we can do this one in your notes, but you don't have to do it a second time when you get to this problem. This problem is telling us that opposite sides of this quadrilateral are parallel. So first I'm going to mark that up. So there I have my opposite sides parallel. I notice that both expressions that have an x are over there, and both expressions that have a y are on the right side. If you think about this, if we extended all these sides, we start to see some of the pictures we were just working with. And 11x plus 4 and 5x become consecutive interior angles. Well, consecutive interior angles are supplementary. So we could say 11x plus 4 plus 5x is equal to 180 degrees. 5y plus 5 and 13y minus 5 are doing the same thing. So for our second equation, we could say 13y minus 5 plus 5y plus 5 is equal to 180. Since they're both consecutive interior angles, we're allowed to make that equation. Lastly, we look at one of these bent angle problems. And the trick to doing these is to draw in what we call an auxiliary line. We're not allowed to say that because an angle is 110 at the top, something down here could be 110, because we don't know that these two lines that are acting as transversals are going at the same angle. So instead of that, what I do is create a third line that goes right through the bend of where those two lines meet. So now we can use alternate interior angles to help us out. So if this angle is 110, I know below it, because they're vertical, that is 110.